Hi, my name is Ioana and my presentation is about Piet Mondrian's last and unfinished work, Victory Boogie Woogie, and Professor Loam Jiffy's article, A Program for Victory Boogie Woogie. His article details a successful attempting to build a computer-generated composition in the style of Victory Boogie Woogie. My presentation also covers my team implementation of Professor Fee's code, converted from the original Java and processing to JavaScript. I will go into detail about themes like Mondrian's artist career, an analysis of Victory Boogie Woogie, programming techniques, fuzzy logic, and design patterns. In order to teach a computer how to replicate Victory Boogie Woogie, I think one must first understand Piet Mondrian's and his art career. Piet Mondrian was a Dutch-born artist who spent his professional life in Paris, London, New York, each city influencing in a way his artistic choices. At the beginning of his career, his painting looked nothing like the compositions that we know of today. He painted landscapes like most Dutch painters in his time, but even then he adapted unconventional techniques like putting the horizon very high and focusing on the ground rather than putting the horizon line very low and focusing on the beautiful Dutch clouds that were popular in paintings at his time. Later, he also experimented with Impressionism, as we see here, being clearly inspired by Van Gogh and showing up an affinity for the primary colors, the bright primary colors that we see later in his most iconic works. Then when he moves to Paris, his attention and his artistic choices take a sharp turn towards Cubism, as he is inspired by Picasso and Braque. Mondrian will start slowly to move away from realistic interpretation and representation and closer to abstraction, as we see in this pictures of a tree and how they start from being impressionistic but quite realistic, besides the red colors and the bright colors, and they go closer and closer to being very, very abstract. Also closely related to Victory Boogie Woogie lays Broadway Boogie Woogie, a departure from his iconic straight black lines and simplicity that we see in the Lichtier movement. Both compositions seem to encapsulate the order from his previous works, but at the same time bring an essence of chaos. The black lines that we see here become colored, as he is also, but it's not a new element, as the yellow lines also start here in this painting on the right. And the composition is, as we see, so much more complex than his previous work. Mondrian believed that this meticulous arrangement would establish a sense of order and balance, reflecting the universal harmony he sought to express through his art. Abstractly, though, his paintings are supposed to mimic the energetic and lively atmosphere of New York. Now I'm going to talk specifically about Professor Lofi's article and his approach of replicating Victory Boogie Woogie algorithmically. One idea was the top-down approach, using regular grids and perturbing it. This idea is supported by Mondrian's earlier work, and he later abandoned it after criticism that all rectangles had the same size, and thus this approach with the regular grids was also abandoned by the author. Other tried and abandoned or partially abandoned ideas include the recursively splitting the planes and its subplanes. The problem here was that the line arrangement needed more freedom than recursive splitting offered. And then we have the bottom-up approach, just drawing random rectangles, But when there is also too much freedom in the position of the rectangles, they will overlap, which is a phenomenon that we rarely see in Mondrian's composition. Another idea would be letting the lines and planes to compete for space on the canvas. It is observed that when the lines are ready, the rectangles in between them can be filled with colors. This is inspired by Mondrian's words. In drawing, the lines are the principal means of expression. In painting, however, the lines are absorbed by the color planes. Because of this idea and this quote, the author decided to leave the lines and planes uh, and treat them as a single unified type called a cell. A cell is represented in the program as a two-dimensional array, as a two-dimensional colored rectangle, and it possesses various numerical and Boolean values that govern its behavior, and its especially its growth behavior. Cells grow from an initial seed, and they interact with their neighbors to find the final position. This allows for a very complex and organic, so that organic shapes are formed that mimic the composition of Victory Boogie Woogie. The cells might grow horizontally or vertically. This is governed by hori and verti. And then they might grow until they reach the border of the canvas, or they are within a small distance, epsilon, away from their neighbors. And this is controlled by stoppy. Some cells grow from the beginning of the program, others wait until they reach their activation age, which stands for other cells to develop first. This precise growth timing, which is crucial in situations where multiple cells are in competition, is regulated by activation, midlife trigger, and age. There's also the variable ratio, which is used to force cells to have a certain height and width ratio, and the value of -1 when there is no restriction. The program uses cell growth, uses the cell growth engine to produce a wide variety of composition types. Cell is just the base class, which is extended by other classes with specific field values and additional fields and methods. Okay, so the first challenge in programming Picture Boogie Woogie would be first to program the yellow grid. As stated before, regular grids was not a viable option, but then the author of the article draws inspiration from Broadway Boogie Woogie. Yeah, we see on the left side. And he takes into consideration special components, including the twin triplets that we see here in the painting, and also that the rectangles at the intersection of a vertical line and a horizontal line are colored and not just simply yellow. And the simulation of vertical lines and twin lines, triplets, and just two lines. They're gonna treat it as two separate lines that are aligned, not as just one line that was cut off. In the Boogie Woogies, Mondrian introduces nesting for the first time in his paintings. Inside the canvas, there are mini canvases. In object-oriented programming, this nesting corresponds to the composite pattern. In the composite pattern, a group of objects is treated as a unified instance of the same object type. These mini canvases here can be seen as a revival of earlier composition. As we see below, this checkerboard type is from his early work of a checkerboard that we have in this slide right here. Then we have the square lines that are present here. Coming back to nesting and composite patterns and programming technicalities. So the unifying type in our program is called a cell. And each cell has a parent, and in some cases also a co-parent. Each cell also has special attributes consisting also of a set of cells. Each of them again has specific attributes and quite possibly another set of cells. The class cell is a base class, and from this base class we create other specialized cell types, which is canvas, H-line, V-line, mini, quad, atom, and micro. In this class, many of these classes are also composites. They contain other instances, even instances of themselves, like mini does. Atom is the base class of this hierarchy. An atom has one color and a position. Then we have the H line, which represents the horizontal lines, and in this case, then the hori variable that we saw here is set to true, and the verdi is set to false, and the same is states for V line, but then the verdi is set to true and the hori is set to false. Mini represents the mini canvases that we talked about here, and micro is just a small cell which has another subcell. Quad is a configuration of 4 white or gray rectangles sharing one corner, as we see this in the picture of Victory Boogie Woogie. Each cell grows from the moment they reach their activation age and until they reach their midlife, which where is there a point where a trigger method is invoked. Each cell subclass, each of these here, react differently. H line and V line wait until the lines are sufficiently matured, and then the trigger method performs a cleanup operation to get rid of cells that have failed to become large enough. A mini also waits to reach its midlife, and only then it begins its recursive development. As we have talked earlier here, we'll let the lines first compete for space, and then we create the rectangle inside. That's including the mini canvases. Talking more about mini, they are the central piece of nesting in this program, and arguably the centerpiece in the whole program, as mini are the elements that truly give character to Victory Boogie Woogie and bring the innovation that differentiates it from Broadway Boogie Woogie. As we see here, Victory Boogie Woogie is so much more complex than Broadway Boogie Woogie and has so much more elements than this painting here, which just has vertical, horizontal lines. Some minis, some very few minis, most are them micro. The key method in the mini is the setup function. See here, this is mediated by the trigger function. The trigger function calls the setup function. And setup function implements how fuzzy logic is implemented. And that's on the basis of 3 data, which is the size, aspect ratio, and nesting depth. And now let's talk about fuzzy logic, because it's an essential element in the program. That's what makes each composition of Victory Boogie Woogie that we create on the website seem completely different, and they are actually different. Fuzzy logic allows for the randomness and imprecision in the decision-making progress, having the goal to make the composition look as natural as possible and apply to the human-generated human-generated Victory Boogie. Fuzzy logic is a generalization from standard logic, in which elements have a truth value of 0 and 1, but in fuzzy logic, statements can have a value of partial truth, such as 0.9, 0.5. A key component in fuzzy logics are fuzzy sets. Fuzzy sets generalize classical sets by associating each element a membership value. And this membership value are the numbers, real numbers, mostly between 0 and 1, where 0 indicates no membership, 1 indicates full membership. And we use fuzzy logic to present and manipulate the vague concepts so it allows us for more nuanced reasoning compared to traditional binary logic of 0 and 1. So because size, aspect ratio, nesting depth are ambiguous notion, the decomposition of a mini is best made using fuzzy logic. A cell size is broken down to 4 fuzzy predicates: tiny, small, medium, and large. And nesting depth is expressed via recursible. Then aspect ratio is broken down into h squared, p stretched, squarish, and square. As you see, h stretched here, v stretched, squarish, and square. Then all these fuzzy logic use the function fuzzy to calculate specific membership values based on different criteria. Then the setup function randomly selects case, then choose the appropriate decomposition of a mini based on these calculated membership values. There are 21 cases we see here, and a setup function, and that leaves mini a very interesting playground and with no definite answer, very intuitive answer every time. It's very, very random. Here are you can see some pictures of minis reconstructed by the program using nesting-based fuzzy logic. Okay. Also, design patterns are an very important topic in this article and in this program. We have mentioned before that we use composite pattern in nesting, but the program also uses several other design patterns. We have the flyway pattern, which is primarily used to reduce the number of objects created and to decrease footprint and increase performance. The author uses flyway pattern in the color class. Colors are coded as objects with the string label, but they are shared to prevent pixel having its own color. And we have the state pattern, which allows for object to change its behavior when its internal state changes. So in the code, this pattern is used in variables horizontal and stoppy, that is like define how a cell will grow. And the author also implements the template pattern, but it was partly lost due to the limitation of JavaScript in comparison with Java. And one function that still uses the template pattern is trigger. But trigger also does not follow the traditional guidance of a template pattern. So a skeleton of a meta in this case, and then subclasses fit in the details regarding to the situation. But rather, trigger method is defined differently and independently, almost in every class. But all the implementation fulfill a single goal: to decide what to do with an object after it reaches milk flag. So conclusions. This paper has been incredibly insightful, both on a cultural and professional level. I believe I've learned so much about Mondrian after trying so meticulously to understand Victor Boogie and the code that attempts to replicate variation of it. This whole project felt like making a puzzle. Each piece felt just a chaotic and meaningless piece when observed individually. But when everything was pieced together, one could observe the harmony and order of chaos that Mondrian wanted to portray. So this is the program in action. As you see here, the line formed and then the rectangles and the minis come, and then the quads here. This is the place where we could, the program could use some improvement because the quads seem to be way higher than the boogie woogie composition. We can try to start it again. As you see, the horizontal lines on the quads go first, and then the vertical lines, and then the atoms here on the vertical lines, then the rectangles start to come by, and then some other mini canvases that form there. As we have the small checkerboard type that's very Mondrian, a lot of other checkerboard types. And here smaller ones, we have some micros, which is just the rectangle with the mini inside, the micros here. Yeah, let's try it once again. Each composition is very unique, nothing like the other one. We've also implemented a download button. People like find something that they like. Yeah, some other improvement would be to make it more painting-like, so that it mimics more the Mondrian. Not very close by because of the regular grids, not the regular grid, the grid with the yellow lines. If we see at the Victory Boogie Woogie painting, the lines are not so pronounced. They are very subtle and they lose themselves in the mini canvases. Yeah, but all in all, the project was like very much fun. We learned a lot. Yeah, thank you for the attention to my presentation.